In this IDU problem, we want to calculate how much heat is released, here we go, through the complete combustion of propane. So since this is topic, I think 6.7 on bond enthalpies, we're going to approach calculating the energy or the heat released a little bit differently. If you look at the bottom left-hand corner of your handout, there is a table of average bond enthalpies. And so in discussing enthalpy, we talk about bond breaking, uh, taking energy or having to put energy in to break a bond, but when you form bonds, energy is being released. So to calculate the overall enthalpy of a reaction, one of the things we can do is just compare these two energies. So we're going to take the sum of the enthalpy of the bonds being broken, and we're going to subtract the enthalpy, the sum of the enthalpies of the bonds that are being formed. So we're going to look at the difference between the two and figure out then how much heat is released, or sometimes absorbed. But in this case, it says it's released, so we probably should get an exothermic reaction here. But let's see. It's not that the math is difficult with this, but it can be a little time consuming because we really need to see what types of bonds are being broken, look at them all kind of individually and compare them to the bonds that are being formed. So one of the best ways to go about this particular problem is through drawing Lewis structures. So we're going to start with the reactants, which is propane, C, 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 and there are 8 H's around it. So 1, 2, 3, 4, 5, 6, 7, and 8. And we also have 5 oxygen here. And oxygen is O double bonded to an O. And we've got 5 of those. One more. And then the products we're forming 3 moles of CO2. So carbon, oxygen. So we're going to draw 3 of those to represent the 3 moles of carbon dioxide being formed. And then the other thing that we're forming is 4 water molecules, or 4 moles of water. We're looking at that as moles. Let's see here. And if you take a look at the units for bond enthalpy, it is going to be kilojoules per mole. So we're assuming each one of these bonds represents a mole of bonds. So what we're going to do is we're going to take a look and we're going to compare bonds broken versus bonds formed. Bonds formed. Okay, let's see if I can get a straight line there. All right, so I'm going to change my color here. Let's go ahead and do the carbon-hydrogen bond first. So I'm going to go through, I'm going to count all those up. 1, 2, 3, 4, 5, 6, 7, 8 on that side. So I've got 8 carbon-hydrogen bonds, which means I'm going to have 8 times the molar enthalpy, which is 413 kilojoules per mole. Let's go ahead and take a look at carbon-carbon bonds now. We look at carbon-carbon bonds. I only have 2 there. So we've got 2 carbon-carbon bonds, and they're single bonds. Notice they've got carbon double bonds, carbon triple bonds, so make sure you pick the right ones. So that's going to be 2 times its bond enthalpy, which is 348 kilojoules. And then also on the reactant side, we've got oxygen. So 1, 2, 3, 4, 5. So we have 5 oxygen double bonded to an oxygen. So again, look for the double bond, 5 of those. So we're going to multiply that by 480, oops, I think it's 495 kilojoules. Hopefully that's right. All right, so we're going to go ahead, we're going to multiply that all out, add it together to get a total enthalpy for the bonds being broken. I got 6,475 kilojoules. So that's how much energy has to go into breaking the bonds. Let's take a look at bonds formed. So on the other side, Let's go with our carbon double bonded to oxygen first. 1, 2, 3, 4, 5. Looks like we've got 6 of those. And so the bond enthalpy for that is 799 kilojoules. And then we have what? Hydrogen, oxygen single bonds. 1, 2, 3, 4, 5, 6, 7, and 8. 8 oxygen single bond hydrogen. And so the bond enthalpy of that is 463 kilojoules. So there's a J in there somewhere. There we go. Okay, so the total enthalpy that is given off from the bonds being formed is 8,498 kilojoules. There we go. So we're going to take bonds broken. Let's call this enthalpy of bonds broken minus the enthalpy for bonds formed. And that symbol that they use is a sum symbol. I'm not going to write that out, but we've got 6,475 kilojoules minus 8,498 kilojoules. Going off the page. That gives me an overall change in enthalpy for the reaction of negative 2,023 kilojoules. That's it.